Hello, everyone. It's a pleasure to be presenting from Saudi Arabia for the Global Satellite Servicing Forum 2022 Spotlight Talk. This discussion will cover the ISAM paths, tasks, and milestones for a sustainable and thriving new space economy. I'm Stephen Dare, CEO of Protean Industries, and presenting with me are Adam Tenier, our Chief Robotics Officer, and Andrew Bodenberg, our Chief Legal Officer. Let's get started. Focusing on the critical path to a thriving and sustainable space economy begins with the Artemis return to moon missions. Narrowing the path highlights milestones to reach the future ISAM ecosystem. The first step on the path is the development of a new international framework and standards to ensure quality, safety, and efficiency of space access globally. Moving to near-term tasks, continuity of return missions to bolster reciprocating investments in sustainable infrastructure is a vital stepping stone. The next step is commercialization of new operations as a stabilizing force for ISAM maturity, as systems of systems begin to provide overlapping integrated products and services meeting humanity's needs on orbit and beyond. Finally, space solar power stands as the premier OSAM service to contend with existential issues related to global energy concerns. This is the Protean vision to improve reality through understanding.
Human activities in outer space are conducted under the framework of the Outer Space Treaty. When this treaty was created decades ago, many of the activities which we are currently contemplating in outer space simply did not exist, and many of the things which we are now considering were unforeseeable. This is particularly true with commercial operations, which the treaty did not cover at the time of space exploration, largely meant the United States and the Soviet space program. Many legal concepts, particularly property rights, cannot function the same way in space as on Earth without harmful consequences, because humans have not previously owned or used space. To ensure a peaceful use of outer space, we are proposing that we have a legal system based not on ideas such as terra nullius, which would allow vast tracts of space to be claimed as private property, but rather on a basis of cooperation between different actors in outer space, which is consistent with the spirit of the Outer Space Treaty and will also lead to better consequences for everyone involved in the long run.
Moving into the next 5 years, ISAM evolution will require materials, equipment, and services, cycling from planetary surfaces to orbital insertion and back to the surface. This will respond to reduced launch and landing access to contend with gaps in infrastructure, contingency planning, and active environmental knowledge. Protean Industries Protean aims to deploy telerobotic and autonomous rovers via satellite hubs to planetary surfaces to provide mobile ground stations, care packages for human operators, and rapid response services. Deploying rovers from orbit via satellite can ultimately provide continuity of communications and observation for sample return missions, space traffic management, and contingency services on the Earth and Moon. These steps will propagate ISAM infrastructure development and cislunar orbits, as well as maintenance, repair, and upkeep of the lunar gateway. Protean will provide the autonomous eyes, ears, hands, and backbone to enable persistent operations in remote, austere environments during intermittent human occupation.
A growing number of missions, such as EV2, ELSA-D, DART, OSIRIS-REx, Hayabusa, and the Mars Sample Return Experiment, demonstrating the range of capabilities for complete life cycle, ground-to-orbit to ground operations. This will develop positive feedback incentives to expand services beyond Earth and provide return missions back to the surface. MEV-2 and ELSA-D provide the groundwork for establishing and maintaining sustainable orbital access. DART, OSIRIS-REx, Hayabusa, and the Mars Sample Return are providing insights into innovative space mining activities, which can potentially supply rare and valuable resources for scientific and economic advancement on Earth, as well as developing capabilities for asteroid deflection, impact, and capture. Research on 3D printing in zero-G, literally providing the foundation for large-scale infrastructure development, will help overcome some current obstacles in space object deployment. The next steps will include the safe return of equipment back to the Earth from orbital and planetary positions, providing in situ observations for operating in these environments, and yielding new engineering methods to better explore them. These tasks will ultimately define the goals of providing fluid and continuous services from Earth to the rest of the solar system. There is a pressing need for new energy infrastructure and resources within a 10 to 20-year deployment scope, so the time for space-based solar power has arrived. Technology has evolved, capacity and capabilities have changed, and because of this, the benefits will quickly outweigh the costs. Land and sea-based solar antenna arrays supplied by wireless transmission via laser or microwaves can provide power around the clock and all year long without the kind of heat and carbon emissions generated by fossil fuel sources. The system is designed to be flexible and can be redirected to areas where peak demand is high. Additionally, the energy densities of these platforms do not pose an exposure hazard to humans at ground level. Once the system is launched and operational, it is expected to outcompete non-renewables like oil. The successful launch and deployment of the James Webb Telescope and others have proven that compact and expandable structures are viable design options for placing large microwave arrays into orbit. The Parker Solar Probe Shield can provide guidance about how to manage the substantial thermal loads a system like this would experience. A successfully deployed array would also provide a power source for many potential on-orbit and in-space servicing, assembly, and manufacturing operations, planetary construction maintenance, and also space debris removal ventures. Space solar needs to be considered as an enabling force for these capabilities.
We hope that a new international framework developed within this timeline continue fueling the new space economy beyond the Artemis course by 2025. Moving forward, commercial operations should mature by 2028 and continuity of return missions by 2030. Finally, space solar concept development and the production of space solar will come after. These are some critical tasks and milestones to ensure the successful ocean diagram economy. We hope that the use of space and the exploration of space will continue into the future for the best interest of humanity. Thank you for hitting our spotlight hub, and we look forward to your new ISAM.